In this video, we're going to look at rectilinear motion. This is basically a type of motion that proceeds in a straight line. Now, there are some equations of motion that you need to know. So let us start with acceleration. Acceleration is basically the change in the velocity of a body that is in motion with respect to time. So I might represent acceleration as small a, and that is equal to v minus u divided by t. So if I have this, I could use t and multiply it with a. So that is going to give me at. This will be equal to v minus u. Now I could make v the subject of the formula. That is by taking a negative u to the other side. Or rather, I could just add positive u to both sides. So that will be plus u plus at, and this is equal to v minus u plus u. So by this, u gets cancelled out from the left, or the right rather, and so v will be equal to u plus at. So this is actually the first equation of motion. V is equal to u plus or minus at. Now, as you can see, we have two symbols. We have plus at, and we also have minus at. Now, why is that? So the reason why that is there is as a result of the fact that you could have v equal to u plus at. And this is actually in a situation where the vehicle or the body or any object at all in motion is moving or increasing in acceleration. So that will be a positive. But if you have that body decreasing in its acceleration, the form of that motion would actually be called deceleration or retardation. And so what you need to use u minus at. So that is the reason why you have a positive and a negative, in case you have a deceleration. Now, what is average velocity? So I'm just going to write that as average velocity. That will be v average. Now, average velocity is basically the sum of the final velocity and the initial velocity and divided by 2. So v stands for the final velocity, and u, that stands for the initial. So this basically is a formula for average velocity. Now, displacement is written as s, and that is equal to average velocity multiplied by time. Because velocity, or average velocity rather, that is equal to the displacement divided by time. So if I wanted to make displacement the subject, that is going to be average velocity multiplied by time. Now with that, I could substitute this for average velocity. So that is going to make it s, which will be equal to v plus u divided by 2. And this is multiplied by t. Now we know that u is equal to this stuff up here. So I'm just going to substitute that. So we'll have u plus or minus at, and we have a plus u. So this whole thing is divided by 2. And we have multiplied by t on the other side. So if you added u to u, that is going to give you 2u. And so we have 2u minus at divided by 2. This is multiplied by t. So I could use t and FOIL this bracket. So that basically has a t multiplying with 2u and with at. So that gives us 2ut. Well, there should be a plus here. So this will be plus or minus at squared. That is divided by 2. Now, I know that if I have two numerators which has a single denominator, I could actually split this. This could be written as A over 2 plus B over 2. So I'm going to use that principle for this process. So the next step here, we should actually have 2ut over 2, and that will be plus or minus at squared over 2. So I know that 2 cancels out here, and so we should have s, which will be equal to ut plus or minus 1 over 2 at squared. So this is going to be the second equation of motion. S is equal to ut plus or minus 1 over 2 at squared. Now, hopefully you know the reason why the plus or minus is present there. Now, let us try to find the last equation of motion, because we basically have 3 of them. So first off, you know that S is the same thing as V minus U. Whoa, yeah. Let me rather use this one. V plus U over 2. That was multiplied by T, right? Now, this is what I'm going to do. We also know that A was equal to V minus U divided by T. And I actually have T on this other side. So what I'm going to do, I will make T the subject. So that makes it V minus U divided by A. So I will use this and substitute it for T, the equation of the displacement. So that makes it to be S, and this is equal to V plus U over 2. And that is multiplied by V minus U over A. In this case, we have T as V minus U over A. Now, if we multiply this stuff, this would give us V plus U multiplied by V. So I should write V rather, minus U. And this is all divided by 2 multiplied by A, which is 2A. Now, if I multiply these two stuff, I would basically have a difference of 2 squares. Something like this. Because if you multiply V by V, that should give you V squared. And V multiplied by U, that is negative UV. And U multiplied by V, that gives us some positive UV. And finally, U multiplied by negative U should give us negative U squared. So negative UV plus UV gets cancelled out. And what we have left is V squared minus U squared. So that is basically what the whole stuff is going to change into. So I just need to wipe this stuff out. Yeah. So as it is, we have the displacement to be V squared minus U squared divided by 2. Now, I could use 2 to multiply S. Whoa, that is actually a mistake. I didn't add 2A. So there is supposed to be an A with the 2 there. So this gets multiplied with the displacement. So that makes it to be 2AS, and this will be equal to V squared minus U squared. So I want to make V squared the subject. So how's that going to look? Okay, so this is going to be V squared, and you're going to have U squared plus or minus 2AS. Now, of course, there is actually just a plus here. But as you know, we're talking about retardation and acceleration. So there should always be a plus and a negative in case of whichever situation we're actually operating on. So this is the third equation of motion. Let me wipe this out and write it better. So we have V squared is equal to U squared plus or minus 2AS. Now, these equations, they are actually equations in a horizontal pattern. If you have a body moving in a horizontal direction, then you would actually use these formulas to find out what will be the velocity or the distance, or I should rather say displacement, or the time, and also the acceleration with which this motion is being carried out. But what if you had a vertical motion, a motion that might be against gravity or toward gravity? What are going to be the equations of motion that you would need to use? Now, bear in mind, these are for the horizontal motion. Okay, so this is a horizontal rectilinear motion. So you need to use this once. Now, the equations that you get to use for a motion toward gravity or against gravity, you just need to change the acceleration to g. Because in that case, we're actually going to have these motions working against the acceleration due to gravity or working toward the acceleration due to gravity. So let us write that one. Now, first off, we have v equal to u plus or minus at. So in this case, we are not really going to use a. We're just going to change it and make it a g. So the whole stuff becomes v, and this will be equal to u plus or minus gt. Now you need to know that g is approximately 9.8 meter per second squared. Now the values of the acceleration due to gravity, they change at various positions on the earth. If you have the earth at this place, these are actually the poles of the earth. Now the values of acceleration due to gravity are better at the poles of the earth than the equator. So at the equator, you have the values of acceleration due to gravity to be lower than at the poles of the earth. So just bear that at the back. Now, if you have a motion in a direction to gravity, that is motion due to gravity, what is going to be the real equation of velocity that you're going to use? So if it is going toward gravity, that is going to be a downward motion. So that would rather be a free fall. And so the equation that you need to use v is equal to u plus gt. Now that is if you wanted to find the final velocity with which that motion is being carried out. Now the positive is as a result of the fact that the motion is toward the center of the earth. But if you have the motion going away from the center of the earth, the velocity with which that motion will proceed would actually be u minus gt, because in this case you have a negative motion. You have a motion that is opposite to the direction of gravity. Now the direction of gravity is basically downward. So every motion that is in the same direction with gravity gets added to the initial velocity rather. And any motion that goes away from the direction of gravity, that is going to get subtracted. That is going to have a gt be subtracted from the initial velocity. So that works for every other equation that we're actually going to look at here. Now we also have the second, the displacement, which is ut plus or minus 1 over 2. Well, 1 over 2 at squared. So instead of using this a, I'm rather going to use this one. So s would rather be ut plus or minus 1 over 2 gt squared. Then if I have a v squared is equal to u squared plus or minus 2as, in this case I would rather use v squared. That will be u squared plus or minus 2gs. So if we have the motion being carried out against gravity, you're actually going to use negative of the values here. But if you have the motion being carried out toward gravity, that will be a positive. So you would always use a positive g. If it is against gravity, you're going to use a negative g. So that is basically what we have. Now next up, we're going to go look at some questions under the equations of motion. Now here are some 4 questions which we want to look at under the linear motion. So the first question says, a particle starts from rest and moves with uniform acceleration 1.0 1.2 meter per second. So that should be a 1.2 meter per second squared. That is an error there. So the question is, what is its velocity after 20 seconds and how far has it moved in this time? So we need to solve that using the equations of motion. Now let us bring out the parameters. We have that the particle started from rest. That means we need to have an initial velocity which will be 0. Because the initial velocity, that is the beginning velocity, and we said that the particle started from rest. So at that time, the velocity was equal to 0 meter per second. And so they said it moves with uniform acceleration, and the uniform acceleration is 1.2 meter per second squared. So we need to write that there. I'm going to rewrite it. Whoa. Now, the next thing they said is, what is its velocity after 20 seconds? So the time has also been given. That is going to be 20 seconds. And we are required to find the velocity and also to find the distance, or the displacement rather. So how can you do this? How can you solve these questions? Now that should actually come off very easy because you have various equations ready for you. Now let us try with the first one. We have V, which is equal to U plus or minus AT. So which symbol should we use? Should we use a plus or a minus? Now you need to know that this is actually acceleration. So there is actually an increase in the speed with respect to time. That is going to be acceleration. So what you need to use positive. So specifically, we use U plus AT. Now we have U to be 0 and A, that is 1.2, and a time, that is 20. So we need to multiply this. If you multiply 20 by 1.2, that should give you 24 meter per second. So this will be the velocity of the particle. Now the next question is for us to find the distance, or I should rather say displacement rather, for its motion. So what is displacement? Now there is actually many formulas that you could use. You could use this one, ut plus 1 over 2 at squared. You could also use v squared is equal to u squared plus 2as. Now it's also possible for you to use this one. Displacement is equal to average velocity multiplied by time. Now let us use each one of them gradually and see if the answers agree together. Now let us start with the first one. So here we know that u, which is the initial velocity, that is 0. So basically this is going to be 0 multiplied by 1.2. And this is plus 1 over 2 multiplied by a. Now a was told us to be 1.2. Now time was 20 seconds, so I need to write 20 squared. So let us see that. This is basically going to give us 0. So this is multiplied by 1 over 2 multiplied by 1.2 times 20 squared. So that gives us 240. And that is meters. So that is what we have, 240. Now let us try this other formula. Is it going to give us the same answer? Let us find out. Okay, so we have a v squared, and that is equal to u squared plus 2as. Okay, now we need to find the displacement, which is s. So we need to make that a subject. This is going to be 2as, and this will be equal to, instead of doing that, let me go more gradually. So what I'm just going to do, I will just place in every value. We have v squared to be 24 squared because the velocity is 24 meter per second, and u squared will be 0 squared. So we have 1.2 and then we have s there. Now we know that this should obviously be 0. So this is 24 squared. And that is equal to 2 multiplied by 1.2. So that should give us 2.4 multiplied by s. So s should be 24 squared divided by 2.4. So let us find out. Yeah. So that still gives us 240 meters. So as you can see, the value of the displacement using this formula is the same as the one found using this other formula. Now let us try to use this one. Is it going to give us the same answer? Now if it does, we're now going to find out the reason why it's not so possible to always use all the equations in one question. So we have the displacement, which is equal to average velocity multiplied by time. Now what is average velocity? Average velocity, that is v plus u divided by 2. So this should be multiplied by t. Now we know what v is. V is 24 and u, that is 0. This is divided by 2. And the time we had 20. So this is basically going to be 12 because 2 divided into 24 should give us 12. So we have 12 multiplied by 20, which basically makes it 240 meters. So as it is, all these formulas work. So now what is the difference between these formulas? And which one could you actually use for questions? So the basic thing that you need to know is that all the formulas are actually correct and you could actually use any one. But there will be some questions where not all the parameters would actually be given to you. So you get to use the formula which has all the parameters available in that formula. Okay, so if you have it for s equal to ut plus half at squared, then go ahead, use that one. But if you have the one that doesn't have the time, then you need to use this one. V squared is equal to u squared plus 2as. And you're still going to find the displacement without needing to know the value of the time. Then there is also another one, which is average velocity multiplied by time. So that is just the difference. Now, having got that, let us move to the second question. So the second question says, the speed of a car increased from 36 km per hour to 96 km per hour in 0.6 kilometers. So this is actually the displacement over which this change in speed occurred. How long did this take and what was the acceleration? So we need to find the time and to find the acceleration. So this is what we need to do. Bringing out the parameters, we need the initial acceleration. Sorry, the initial velocity. So that is going to be 36 km per hour. Then we also have the final velocity, which is 96 kilometers per hour. Then we have the distance or displacement rather, which is 0.6 kilometers. So we need to find the time and the acceleration. Now, how are we going to do it? So there is actually some simple ways that you could use. As you can see, we do not really have time here. So it's possible for us to use v squared is equal to u squared minus 2as. It turns out to be that we do not also know what the value of the acceleration is. So as it is, we might not be able to use this one. But there is also another. The average velocity multiplied by time actually gives us the displacement. So we could actually use this formula and really might well be able to get the answer. So let us work that one. Right? So this is V average, which is V plus U divided by 2. And this is multiplied by T. Oh, I think I made a mistake. There is actually displacement here. So even if we do not have acceleration, we could actually still use this formula. So that is how good it is. But let us go further. So in this case, we actually just need to find the time. Now, if we find time, we could go ahead and use this formula to find the acceleration. So this actually works. But let us use this one since we have called it out. So here you have a 96 plus 36, and that will be divided by 2. This should be multiplied by t. Now we know that the displacement is 0.6 kilometers, so this should be 0.6. So we have 96 plus 36. What should that give us? So that is 132. So this is divided by 2. This is multiplied by t. So we have 66. This is 0.6. This is equal to 66 multiplied by t. Now finally, we need to find t, which is basically going to be 0.66 divided by 66. Sorry, that should be 0.6 divided by 66. So that makes t, which is the time, to be 1 over 110 seconds. Or I should rather say hours. Now you could also change this into seconds if you want. So let us try to do that. That is in a case where you are actually asked to find out the time in the unit of seconds. If not, this could well fit it. So we know that 1 hour carries 60 minutes. So this should be t. And this is 1 over 110 multiplied by 60. And if I wanted to take it to seconds, I need to multiply by another 60. So that basically is 3600 divided by 110. That gives us 32.73 seconds. So this is what you have, 32.73 seconds. If you do not want to write it this way, you could use this one. That will be the time. Now we would actually just stick to this one because the unit would actually help us in the other question that we have to find the acceleration. So the answer should be in per hour or per hour squared in the case of acceleration. So let me write that somewhere here. We have t to be equal to 1 over 110 hour. So let us go ahead and find what the acceleration is going to be. So we know that v squared is equal to u squared plus 2as. Now we are particularly using positive because we have acceleration. It is not actually a retardation or a deceleration. So that is why we need a positive instead of a negative. So we need to find the acceleration. So that is going to be v squared. Now v squared, what is v? V is 96. So we have 96 squared. And here we have 36 squared. And this is plus 2as, right? So this is actually going to go to the other side. So this is 96 squared minus 36 squared. And this is equal to 2as. So 96 squared minus 36 squared, that gives us 7920. And so this is equal to 2as. So the acceleration should be 7920 divided by 2s. Now what is s? S is the displacement, which was actually given to be 0.6 kilometers. So we are going to write that there. This will be 2 times 0.6 kilometers. So that is going to be 7920 divided by 2 multiplied by 0.6. So this is 6600. So A, the acceleration is 6600 kilometer per hour squared. I think I will just wipe this out and write it out more properly. So the acceleration is 6600 kilometer per hour squared. So that is basically the answer to that question. Now let us go on to the third question. Well, So the third question says, a motor car traveling at 54 km per hour is brought to rest with uniform retardation in 5 seconds. Find its retardation and the distance traveled in its time. So we have the third question. Now this is the speed. So let us say that the speed is initial, and that is up 54 kilometers per hour. Now they said that the motor car came to rest, so that makes the final velocity to be 0. Now the retardation happened in 5 seconds. Now retardation is actually going to be a negative value, so let us say that is negative x. We don't know what that value is, but we're actually going to find it. So let us make it to be a negative x. Now whichever value we have for a, that is going to be a negative of that value. Then we have time, which is 5 seconds. So let us find the retardation. We know that v is equal to u plus at, right? So what is v? V is 0, and u, that is 54. Now we have at. We know that t is 5, that is 5 seconds. Well, there is actually some problem here. We find that this is in seconds and this is in kilometer per hour. So what are we going to do? What I'm going to do is to change these seconds into hours so that we would have a uniform form of units. So how many hours are in 1 second? We know that 1 hour is equal to 3600 seconds. So if I divide it through by 3600, this is going to cancel out and make it 1 second. So that makes it 1 second, and that would basically be equal to 1 over 3600 hours. Okay, so that is what we have. So let us see what that will be in standard form. So this makes it 1 second being equal to 2.78 multiplied by 10 raised to the power of negative 4. So this is what you have. 1 second is equal to 2.78 times 10 raised to the power of negative 4 hour. So I'm going to multiply that by this. This should be something 5. Well, I think I'm going to write out on another. So this will be 5 multiplied by 2.78 multiplied by 10 raised to the power of negative 4 hour. So that is what we have there. Now, I'm just going to add this here. So this makes it to be 2.78 multiplied by 10 raised to the power of negative 4. So I need to find a, the value of a. So what I need to do, I need to take 54 to the other side. So that makes it 54 or negative 54. So this is going to be a multiplied by the same stuff. Now, I really don't want to rewrite that. Let me just write it. So that is 5 multiplied by 2.78 multiplied by 10 to the negative 4. So we have a. A will be negative 54 divided by this stuff. Actually, some long figure. So this is 2.78 multiplied by 10 to the negative 4. And the acceleration would actually be in terms of kilometer per hour squared. So let us see what that should give. So that gives us 38,848. Well, 0.92. Now you know that this should be kilometer per hour squared. So that is going to be the unit of acceleration in this situation. Well, this is actually the numerical value. 38,884.92 kilometer per hour squared. That is the acceleration, or I should rather say retardation. So this is actually supposed to have a negative. I should just place a negative there in front of the value. Now next up, we need to find the distance that was traveled in this time. So by now, you should be able to find out what that distance or displacement is going to be. We are going to use v squared is equal to u squared. So this will be minus 2as. Because we have the acceleration to be a negative stuff, that is a deceleration. So we need to find the displacement. Okay, so I'm going to take this to the other side. This will be 2as, and this is going to be u squared minus v squared. So what is s? S will be u squared minus, I need to rewrite this, u squared minus v squared divided by 2a. So let us see what that gives. Now u squared, we know that u was actually the initial velocity, which is actually 54. So I should write that 54 squared minus the final. The final will be 0 because the stuff was brought to rest. So that will be 0. 0 squared is 0. Now we have 2 multiplied by the acceleration. Okay. Now the acceleration is 38.8. So that is 38,848.92. Now you do not necessarily need to add the negative for the power or in the equation, because that is basically trying to tell you the direction or the type of acceleration that was happening there. That was a retardation. But in this case, we're actually dealing with distance, and you cannot actually have distance to be a negative value. So that is the reason why you do not have a negative in this place. So let us find what that's going to be. We have 54 squared, and that is divided by 2 multiplied by 38848.92. So the distance in kilometer, that is going to be 0.0375 kilometers. So that will be the answer for the displacement. Now let us find the answer to the fourth question. So the fourth question says, a body projected vertically upwards with a velocity of 49 meters per second. Find the greatest height reached and the time taken. So vertically upward, we find that this is actually a motion that is actually against gravity. So that is going to be a negative g, right? Just a nugget that you need to know, by the way. Now we have the velocity with which this stuff happened. So that should be the initial. That is going to be 49 meters per second. So we are asked to find the greatest height that was reached. Okay. Now the greatest height obviously will be at the time where the velocity is equal to 0, the final velocity. And that is actually reasonable, because if you throw a projectile or a body upwards, it's obviously going to reach a level in space where it cannot actually go further. And so that will be the greatest height. Now that place where it cannot proceed is a place where the velocity has ended. And that is going to be the final velocity at that time. So that will be 0. And the initial velocity is the velocity with which it was projected into the sky. And in this case, we have 49. So that is going to be 49 meters per second. So that is what you have. Now going back, we need to find the greatest height. Now the greatest height, that could be written as of the displacement. Now what is going to be the formula that we should use for this question? So basically, I just need to use v squared is equal to u squared plus or minus 2as. But there will be a change in the symbols and some of the terms that I need to use here. So first off, I don't need to use a positive because the motion is actually going against gravity, so I will actually use a negative. So that is going to be v squared, and we have u squared, but I will have a negative here. Now, I'm not also going to use normal acceleration, but the acceleration due to gravity. And this is actually reasonable because we know that the value of g is a constant, and that helps the question. So in this case, we have the displacement, which is actually going to be written as a height. I think I'm going to rewrite that. So this is actually the height. Now I need to find the height. So what I'm going to do, I'm going to take this to this other side and switch positions with the final velocity. So this is u squared minus v squared. It's a fortunate one that the final velocity is equal to 0. So that will basically be u squared minus 0, which is the same thing. If you squared 0, that is going to be 0. So basically, v squared gets cancelled out. Now the height is going to be u squared divided by 2g. So u, that is 49, and we need to square it, and then we have 2 multiplied by g. What is the value of g? On n, you basically have an approximate value of 9.8. So that is going to be 49 squared divided by 2 multiplied by 9.8. So this is 122.5. So that basically should be in meters. So this is the velocity over which the projectile was displaced. Now we need to find also the time that was required for this motion. So which formula should we use? Now it's very possible for us to use this one. V is equal to u minus gt, or you could also use S is equal to, or I should rather say H in this case. Let us start with the original equation. That is supposed to be ut minus 1 over 2 gt squared, right? But I'm just going to use H because in this case we're talking about the height, which is a vertical distance above the ground. So this is what you have. And so if you want to find the time, this is actually going to be hard because you need to solve a quadratic equation. So we'd rather not use that one. So I'm going to wipe this out. And we will basically use this one. Okay. So we know that the initial velocity is 49 and the final, that is 0. We know the acceleration due to gravity. So it is just the time that we're left with here. So that is going to be gt, and this will be equal to u minus v. So the time will be u minus v divided by g. We know that u, that is 49, and v is 0, and g, that is 9.8. So that should be 49 divided by 9.8. So that gives us 5. So we have 5 seconds. That was basically the time that the projectile launched into the sky. So the highest amount of time it was there is actually 5 seconds. It used 5 seconds to reach the greatest height. But of course, as it goes to the greatest height, that is 5 seconds, right? So it uses 5 seconds to reach the maximum height. Now there is also an amount of time that will be taken to return from that height, which is still going to be 5. Because if you had 5 seconds going this way, you're also going to have 5 coming down. So approximately you should have something close to 10 seconds. That is going to be the total time that the projectile spent in the space or in the atmosphere. So this is the answer.